At 10:23 local time on May 9th, 2025, a Ukrainian MiG-29 from the 40th Tactical Aviation Brigade rolled sharply into a banking turn, cockpit lighting up with cascading voltage alerts. Up until now, the strike run toward a Russian drone assembly complex had been uneventful. That changed in less than 5 seconds. The pilot's radar warning receiver screamed. An S-300 batteries acquisition radar had just painted his aircraft from 93 kilometers out. He shoved the stick forward, dropping to 470 feet and hugging the undulating landscape, letting terrain shield him from the incoming electronic gaze. Meanwhile, his weapon's interface was deep into its boot-up process. Each GBU-39 small-diameter bomb had to secure a GPS lock, align its inertial navigation system, and handshake with the improvised Ukrainian control link. The entire startup was designed to take half a minute. It had already dragged on for more than 2 minutes. At 10:26, all 4 bombs finally flashed green. On the ruggedized tablet mounted to his dash, coordinates pulsed into focus. A drone manufacturing hub 355 kilometers inside enemy territory, producing roughly 43 Shahed 136 a week. Satellite imagery showed a Kushuka-4 electronic warfare vehicle on site, flooding GPS bands with 500 watts of interference. Fuel checks told a brutal truth. After weapons release, he'd have 17 minutes over enemy ground before bingo fuel forced a return. The S-300's scan pattern intensified, joined by a mobile SA-15 radar sweeping from the southeast. In 5 minutes, he'd have to climb to 15,200 feet to release the bombs, exposing himself to every long-range radar in the sector. From that altitude, the GBU-39s could glide 111 kilometers, but their initial guidance phase would have to survive an electromagnetic assault strong enough to fry most commercial electronics. A sudden 31.1-volt spike hit the pylon adapter systems, drawing 32 amps through wiring rated for 20. Somewhere in that battlefield hybrid of NATO and Soviet components, Ukrainian engineering was forcing 2 generations of incompatible electronics to cooperate. He pushed the throttles forward. Twin RD-33 engines answered with 18,300 pounds of thrust each as the MiG crossed into contested skies at 10:29. In a blink, his threat receivers lit up. S-400 tracking from Melitopol, SA-15s redeploying to intercept, and the first ripples of GPS jamming bleeding into his systems. 18 minutes. That's all he had to prove that 4 smart bombs strapped to salvaged tank part pylons could survive the densest air defense net outside Moscow. 10:35. He slipped into a 7.9-kilometer wide gap between overlapping S-300 radar cones. The route, mapped with painstaking satellite passes, threaded between 2 ridgelines for exactly 7 minutes of low-level flight. 2 kilometers too far west, and the S-300 would acquire him. 3 kilometers east, and an SA-15 patrol could engage. 2 minutes later, the RWR pulsed with a new contact. A mobile SA-15 had gone stationary, a clear sign of suspicion. Its operators brought their 9S-36 radar to life, probing for exactly the kind of low-altitude intruder he was. He shoved the MiG even lower, skimming at 380 feet above a dried riverbed, power lines whipping by close enough to scrape paint. At 10:41, he yanked the nose up into a 4G climb toward release height. Multiple fire control radars locked instantly. The S-400's Gravestone radar burned through Ukrainian jamming with 350 watts of coherent energy, enough to warm the MiG's radome. He had 91 seconds to complete the launch before stepping into the S-400's 48 N6E missile envelope, weapons that could hit him in just 25 seconds once fired. The preceding hours of seed strikes, false radar echoes, and decoy attack vectors had been crafted to create this fleeting window. Level at release altitude, he glanced at his fuel readout. 11 minutes left for the return leg. The bomb's GPS receivers were locked to 5 satellites, showing plus or minus 3 meters accuracy despite the Kushuka-4's barrage. The nearest SA-15 battery sat 42 kilometers southwest, outside launch range but too close for comfort. The jamming was brutal, saturating L1 and L2 frequencies, but the GBU-39s were built to shrug off Soviet-era brute force. 10:43:08, the first bomb dropped. The MiG jolted upward as the 250-pound weapon fell clear. Within 200 milliseconds, the GPS signal had crashed, and the bomb's brain had seamlessly switched to inertial navigation mode. 3 more releases followed in quick succession, each bomb snapping its wings open exactly 2.7 seconds after separation, transforming into long-range gliders. Their onboard computers calculated attack vectors from multiple angles, timed to strike 30 seconds apart, making it impossible for point defense systems to hit them all. The MiG rolled inverted and dove for the deck. His threat display came alive as SA-15s finally moved to engage. At 10:44:39, two 9M331 missiles streaked into the air. But the geometry favored the Ukrainian pilot. By the time they closed in, he'd vanished behind terrain clutter. The first bomb's infrared seeker found the assembly hall at 10:47:21, with 94% certainty, adjusting its fins for a 68-degree impact to punch through the roof. The second slammed into the electronics programming center 29 seconds later, destroying the drone guidance calibration stations. The third obliterated the drone storage hangar, triggering a chain reaction as 15 to 20 fully armed Shaheds detonated. The fourth hit what was left, erasing the facility. By 10:49, the MiG was screaming home at 400 feet, fuel state critical. Behind him, columns of black smoke rose over 3,000 feet, peppered by secondary blasts as munitions and fuel stores ignited. Russian air defenses threw everything they had. More SA-15 launches, an S-400 search attempt, even a scramble order for 2 Su-35s from Bryansk. None of it mattered. The river valley ahead masked him from radar. The fighters needed 8 minutes to intercept. He'd be nearly inside friendly airspace by then. Crossing the Malakhna River at 10:53, he broke free of effective Russian radar coverage. Behind him, the enemy's most sophisticated jamming system had been outmaneuvered, its brute force interference rendered useless by a bomb designed to fight through it. Post-strike analysis confirmed it. The GBU-39s had held plus or minus 12 meters accuracy without uninterrupted GPS, exactly as American engineers had claimed. Ukrainian improvisation had taken a Cold War airframe and turned it into a scalpel capable of cutting deep into enemy territory and getting out alive.